Welcome to another video, and today we're going to have a look at hyperbolic functions and specifically the equation of the hyperbolic function. This is the first part in a series of videos on the hyperbola, and yeah, as I said, we're going to have a look at the function. So after this video, you should be able to know the components of each of the equation. You should know what each of the components represent, and then apply the knowledge of what you've learned to this video. Let's jump straight into the video. So here we have the equation. Let me just write it down without all of the stuff in here. So we have f of x would be equal to a over x plus b plus q. So that is the equation. A in the equation. This will show you in which quadrant the graph will lie, and then how close or how far that graph is from the axis. X is a point, or the x coordinate of a point on the hyperbola, and then f of x would be the corresponding y coordinate. So it will basically be this 4, 3, that's a point. So that will be x, and that will be y, or f of x. P will be the vertical asymptote. So if you've got your horizontal and your vertical axis there, P will be a point on your x-axis, and a line will go through that point. And then Q will be your horizontal asymptote, so it will be a point on my y-axis, and you will have a horizontal line going through there. And then you need to know the domain, or answer questions on the domain and then on the range. Let's have a look at the effect of A. So A, if A is positive, and then it will lie in quadrant 1 and quadrant 3 on your Cartesian plane. When A is negative, it will lie in 2 and 4. Let's look at these examples down here. F of x is 1 over x. So A is positive there, and it will lie in quadrant 1 and 3. F of x is equal to 2 over x. A is positive, so it will lie in quadrant 1 and 3. Here's another equation. F of x is equal to negative 2 over x. X is negative, so it will lie in quadrant 2 and 4. Let me make that a different color. 2, 4, because it is negative. When A is greater than 0 or greater than 1, then it will be further away from the axis. And when A is between 0 and 1, it will be closer to the axis. Greater than 1, further away. Between 0 and 1, bring it closer. And that's the effect of A. So when A is positive, quadrant 1 and 3. When A is negative, in quadrant 2 and 4. When A is greater than 1, further away, greater, further. And when it's between, or smaller than 1 and greater than 0, it will be closer to the x-axis. Let's have a look at the effect of Q. And what did we say? Q is a point on my y-axis, and there will be a horizontal line going through there. So when they give a sketch or a graph of the hyperbola, and they say show Q, or show the horizontal asymptote, then this will be the answer. Let's look at this example here. F of x is 1 over x plus 2. So that is our Q. That is my point, first of all, on the y-axis. and then my asymptote will be the line going through the y-axis. So when the examiner asks, now in this, look at the sketch and show what is the horizontal asymptote, then you simply say that horizontal asymptote will be equal to 2. That's it. Horizontal asymptote is a point on my y-axis and a horizontal line going through it. Obviously, when this was -2, then that would have been there, and this would have been my asymptote. Effect of P. So P will be a point on my x-axis, but when P is positive, and then my point will be negative. When it is negative, and then and then it will be positive. So here we have +2, and this is obviously plus q there. So this is my P value here. So that would be -2 because it's positive there. And that would be my vertical asymptote. Let's just write another equation quickly. Let's say f of x equal to 1 over x minus 3 plus 4. We said when this value or when the sign is negative, our value will be positive. So it will be +3. So that would be my horizontal asymptote. And just for fun, what would my vertical that would be my vertical asymptote. Just for fun, what would my horizontal asymptote be when we have this equation here? It's +4. We have it there. There's a 4 on my y-axis, and there will be my vertical or my horizontal asymptote. So and it is positive there. So in which quadrant will my graph lie? So now we're testing everything when we get here. It's positive, so it will lie in quadrant 1 and quadrant 3. So that's my effect of P on my graph. So let's just summarize quickly. Here is our equation. A tells us in which quadrant it lies. When A is positive, then it will lie in quadrant 1 and 3. When it's negative, 2 and 4. X and f of x is a point on my graph. Q is our horizontal asymptote. So Q will be a value on my y-axis, and there will be a horizontal line going through there. Q will be a point on my y-axis, and the horizontal line will go through there. P will be a value on my x-axis, and the vertical line will go through there. And when P is negative, and then my value here will be positive, and vice versa. So let's look at a couple of problems or questions that could be asked about the hyperbola when it comes to the equation. Number 1, in which quadrant will f of x lie if f of x is equal to 2 over x? So, in which quadrant? What we're going to have a look at? We're going to look at that number there, which is A. If A is positive, it will lie there, and it will lie there. In which quadrant will lie if f of x is equal to -3 over x? It's negative, so it will lie in quadrant 2, quadrant 4. Easy as that. But you knew that because you went through the video and watched the video. What is the horizontal asymptote of f of x? And show it on the graph. Okay, horizontal asymptote. What part of the equation we're going to have a look at? Q, and Q is that number there. So that's the point on my y-axis, and then Let me show the horizontal line. There we go. That's it. B, f of x is 3 over x minus 1. My q is minus 1. So I'll just put the negative 1 there and just draw the line there. Just for interests. For this one, I will be positive. So where will it lie? In quadrant 1 and quadrant 3. And that's how easy it is. F of x is equal to 5 over x. And that's obviously a 0 there, but they don't show us. So what will my horizontal asymptote be? My point will be 0. And it will lie on my 0 line there. Problem solved. Let's look at the vertical asymptote of g of x. So, what is the vertical asymptote of g of x? And show it on the graph. What are we going to have a look at now? Let me just make it another color here. We're going to look at that value. Plus 4. But remember, what we said was that if that's a positive, it will become a negative. So, that's my point. And then if I need to show it, it will be a vertical line. G of x is equal to 2 over x minus 2 minus 2. Which part of the equation we're going to have a look at? For my vertical asymptote, we're going to have a look at that one. It's negative 2, but we swap that because we change the signs. So, it's negative 2. It will be positive, and that will be my vertical line asymptote. Just for interest sake, let's check quickly what would be my horizontal asymptote of this equation here. Negative 2. There's negative 2, and there's my asymptote. So this line and this line becomes my new axis. And now we can check where the graph will lie. It's positive, so it will lie in quadrant 1 and quadrant 3. Oh, just got lost there for a minute because the stuff is so easy when it's explained like that. I hope you understand. If you've watched this video till thus far, give it a like and subscribe. More is coming. So, final problem. Look at the following equation. 1 over x plus 2, negative 1. What is the vertical asymptote? So from that, let's answer the question quickly. Vertical asymptote, vertical. Oh, let me give it a different color. Vertical, we look at P, and P is positive there, so it will be negative. I'll put my point there, and I put my asymptote there. What is the horizontal asymptote? Now it should be easy for you. Horizontal, look at that one there, it's negative 1. And to my line there, showing which quadrant the graph will lie. Because it's positive, it will lie in quadrant 1 and quadrant 3. And that's how easy it is to keep on saying that. But that is the equation of the hyperbolic equation. Final problem, because you must probably tired if you have watched this video so far. But let's do this quickly. Look at the following equation. Number 1, what is the vertical asymptote? Vertical, look at that number, it's positive 2, negative 2. So we go horizontal asymptote, plus 2. We don't need to change anything there, because there's a plus 2, there's a line. And which quadrant it lies? It's negative 4, so it lies in 2 and 4. And that's it. This has been quite a long video, but if you've come so far, hopefully you would find this video helpful. If you find it helpful, please click the like button, subscribe if you haven't done so, and I'll bring you some more videos. Done.